AP Calculus AB, Unit 10, Day 7, Office Hours. So this is a just two free response problem worksheet. These free response problems pretty much kind of involve most of the things that we've learned in this unit. So this is really good practice, even for your upcoming test. So let's try these out. First one, you're allowed to use a graphing calculator. Still got to show all the setups and stuff. Got to write down the calculus expressions that you're going to evaluate on your calculator if you do use it. Just again to emphasize, these are 9 points each on AP test. The point breakdown for this one was 3, 4, and 2. And let's see if we can try this. It says let R be the region in the first quadrant, bounded by the graphs y equals the square root of x. That's sideways parabola top, and y equals x over 3. That's just a simple line that goes to the origin, slope of 1/3, up 1 over 3. Let's draw a picture. Now, even though we have a calculator, I think this is basic enough that we should be able to draw this picture pretty quickly, and it's going to be good to have it. I don't think graphing on your calculator is actually worth your time. Okay, so we have a sideways parabola. I mean, you could graph it if you forgot what this looks like. We have a line, y equals x over 3. That definitely goes to the origin. Both of these go through there. I think we're going to need to find the intersection of these two curves. So in part A, we're just going to have to find the area of it. And so we definitely need the intersection. So I'm predicting this is 0, 0. And this, I mean, you could try in your head. I think 9 would actually work. 9, square root of 9 is 3. 9 over 3 is 3. So good guess. But you could use your calculator to find this intersection. I think, again, this is simple enough that it would be faster to just do by hand. I mean, this is something we should be really good at, something we might have to do anyways. So move everything one side, equals 0, factor it, get x equals 0, x equals 9, 0, 0, 9, 3, perfect. Okay, so pretty easy to do by hand. Now, part A, we're going to just find the area. So, I mean, we do vertical slices or horizontal. I'm thinking vertical is going to be your best bet. And the area is going to be y top minus y bottom. Not that you have to write this, but that's the length of the slice. And then the width of the slice is dx. So we're going to integrate left to right, 0 to 9. Y top in terms of x is the square root of x, minus y bottom is x over 3. So this is your setup, okay? That's definitely going to be worth, this is actually worth 2 points. The limits being correct is a point, and the integrand is a point, what's inside the integral. And then we can just put this in our calculator. We're allowed to use a calculator, right? I mean, you could do it by hand, but that would not be a good use of your time, and you might make mistakes. So we just do math 9. Square root of x close minus x over 3, comma x, comma 0, comma 9. That should do it. It's working on it. My calculator. Okay, so 4.500, 3 decimal actually round truncated. Now, I bet the exact answer is 4.5, but your calculator's not using exact methods. But, it's pretty good. 6 decimals, it was accurate. Now, you could do horizontal slicing, and, we could show that just for practice, x right minus x left. So instead, you could do x right minus x left, dy thickness, and you would integrate 0 to 3, and x right in terms of y would be 3y, and x left in terms of y would be y squared. So you got to solve these equations for x in terms of y, dy. It's pretty nice. I mean, if you're going to do it by hand, this one would be a lot easier to work it out by hand. Let's check our answer. See if we get the same thing just for fun. Math 9. We're going to put x's for the y's. Same answer. And it was really quick. For some reason, it was easier for our calculator to do that. My calculator. Okay. So that's part A, one way or the other. Doesn't matter. 1 point for the answer, 1 point for the limits, 1 point for the integrand. So you have to show your setups. Okay. It's going to help you get it right, but you're also going to lose points even if you do get it right, if you don't show the setups. Find the volume of the solid generated when R is rotated around with the line x equals -1. So x equals -1. We're going to rotate it around that. So I think we really should draw a picture. Now, I'm just going to kind of squeeze it in here. Doesn't need to be perfect, but I like to see this other half just to visualize it better. And we got to find the volume. This solid revolution. So if we did perpendicular to the axis of rotation, we'd get the disk washer approach, right? Which is what you probably feel more comfortable with right now. I'm going to try both ways. I haven't really forced you guys to do shell method yet, so you might come back to this after maybe tomorrow's lesson and tomorrow's homework and see if you can figure it out. Because I'm going to require you to do both approaches on your next test. On the AP test, it's really up to you. Sometimes it's at the mercy of the information they give you. You can't really necessarily do it one way or the other. But everything should be based off over here. So here's your R, big R, and there's a whole little r. Now it's x right minus x left. So this is a big disk minus a small disk. And a disk is just a short cylinder, pi r squared times the thickness, which would be dy this time. So that's the one trade-off here, is that you're going to have to do it with respect to y if you're going to do disk washers. Minus pi little r squared dy, that's one big disk, one small disk. Integrate to add them all up, all the disks. So the limits in the x direction. Now here's the deal: you don't start here or here or here. You start at the edge. Wait, hold on a second. No, we're going in the y direction. Sorry, we're going in the y direction. So we go bottom to top, 0 to 3. And the big radius is x right minus x left. Now x right in terms of y would be 3y. X left is -1. So because the axis rotation is offset, it's not 0. So we actually have something here. Minus pi, 0 to 3. The little one is going to be x right minus x left. And x right is going to be y squared, and x left is going to be -1. Don't forget the squared. So, I mean, this is good enough for your setup on AP tests. That's going to give you 3 points. 1 point for the constants and limits being correct. If you don't remember the pi, lose it. And then probably 1 point for this and 1 point for this. And then we're going to calculate on our calculator. Now, I mean, we could rewrite it nicer. I mean, this is going to be plus plus. This is going to be plus plus. When I type it on a calculator, I'm probably just going to type it, with a positive. So we're going to go pi math 9 parentheses 3x plus 1 squared comma x comma 0 comma 3 minus pi math 9 parentheses x squared plus 1 close parentheses squared comma x comma 0 comma 3, and we get 130.061 or 130.062. And for sure, I mean, we could do this by hand. It would be a lot of work though. Now the shell approach, just to help you guys start getting going, you would place it parallel to the axis of rotation. Parallel. And you get these thin kind of pipe shells. Okay, now remember, when you open a shell up, it's a big rectangle. And the dimension on the top of the rectangle is the circumference around the shell originally. So when you open this up, it looks like this. And this is the circumference around the original shell, right? That ends up being that. And then you have your height. So the volume of this, don't memorize this, it's this area of this rectangle times the thickness. So it's going to be 2 pi r h times the thickness, in this case, is going to be dx because it's the vertical slice, and then we integrate it. So that's the basic setup. And then, so the dimensions are going to be in the x direction. Now, when you do this, you always use this original region as your left, right, top, bottom your limit. So we're going to go 0 to 9. You're not going to go -1 to 9, because then you would end up calculating a bunch of stuff in the middle here. When there's a hole, you start at the left edge and go to the right edge of where the actual stuff is. So this is different than the shell method, the disk wash method. We're not going to subtract anything later. We're just going to only calculate what's supposed to be part of it, and we can. Now, the radius of these shells is always just x or y as you gradually integrate. So we're just starting at x equals 0 and gradually getting x equals 9. We're going through all the x values along the way, and those give us the radius along the way. It does require you, so it's going to be x right minus x left, and it's just going to be x, whatever x value we're at, minus, we do have to subtract the -1 because the radius is based off of that offset axis rotation. So it's going to be x plus 1. Your radius of shells is always just x or y, possibly plus or minus a number. It does not involve the curves. The height involves the curves. The height is the distance between the curves, y top minus y bottom. Y top in terms of x is the square root of x. Y bottom is x over 3 dx. So that's your setup. And of course, we could do this by hand, but let's try it on the calculator, see if it gives us the same answer. So it's one way or the other. I mean, if you're good at both of these, that shell's, maybe a little simpler. Okay, so we're going to do 2 pi math 9 parentheses x plus 1 parentheses square root of x minus x over 3 close comma x comma 0 comma 9. That should be it. Let's see if we get the same answer. See if we get 130.061. Now, these answers might be slightly off. Look, they're actually off right there at the 6th decimal place because they're estimation techniques and they're slicing a little different. So the results come out a little different. But to 3 decimals, your calculator is good enough to give you consistent results, whatever approach you take. Okay, so the answer was a point. But you guys are going to get more practice with the shell technique soon. C says the region R is the base of a solid. For the solid, the cross sections are perpendicular to the y-axis are squares. Find the volume. I'm going to redraw this picture real quick. Just it's way too messy, and it won't take me that long. Right, and it's worth it. Okay, now it says this is volume by cross section. So this is the base region. I'm going to build off of it, up, essentially. They're perpendicular to the y-axis. So these slices are sideways, and they are squares. So I would draw one of them. That's enough. And I'm going to use that slice to help us set it up now. So the volume is some common cross-section in terms of y this time, which is, they are squares, which is side squared, right? Which is the sides here. You always want to base the side off of this the part of the slice that's touching the base region. So this is your side. It's going to be x right minus x left. X right minus x left. We need to get those in terms of y. So x right is the line. So it's going to be 3y. X left is the sideways parabola, which if you solve for x in terms of y, you get y squared. So your volume is, we're integrating bottom to top in the y direction, 0 to 3, not 0 to 9, 0 to 3. And x right is 3y, x left is y squared. Squared, don't forget that next squared. And that's your setup right there. And we just put it in our calculator. So the points on this, by the way, this is 2 points. It was 1 point, I think, for what was inside here, and then 1 point for the limits in the answer. So the answer, we do math 9, parentheses, 3x minus x squared, close, squared, comma x, comma 0, comma 3, and we get 8.100. 3 decimal accurate. Okay. You cannot do this one vertically. Like finding the area, you can do vertical or horizontal, right? Slices. Finding the volume of solid revolution, vertical, horizontal, same answer, right? Same answer. Volume by cross section is dependent on the direction of slices. It gives you a different answer if you try to do it vertical. Okay, so that's that one. And you've got 15 minutes each to do these. So that took me about 15 minutes, and I did a couple of the problems 2 ways. Okay, this one's going to be no graphing calculator, okay, which means you're going to get more points for the setups. And sometimes you might not have to actually find the final answer. They might let you off the hook for certain parts. And they're giving us the drawing this time, which is nice. Let R be the region bounded by the graphs y equals the square root of x, which we, so it's just because they give it to you doesn't mean you don't have to be able to identify which shape is which. That one's a straight line. They both go through 0, 0. They gave us this intersection point, so we don't have to do anything with that. So we just need to find the area first. So we do vertical slices, y top minus y bottom, dx, which probably be what most people would want to do. So y top in terms of x is the square root of x, y bottom is x over 2, dx. We're integrating the x direction 0 to 4. So that's your setup. The point breakdown on this problem, the 9 points total, right? So it's 9 points. It's going to be 3, 3, 3 this time. This is your setup, right? And got 1 point for this. Actually, we can get less points for setups here because we actually have to show more work. I kind of said that the wrong way. If you have this calculator, you usually get more points for the setup because then you just put it in your calculator. But this time we actually have to integrate this x to 1/2, so it's x to 3/2, divide by the new exponent, minus x squared over 4, 0 to 4. So this is a point. The antiderivative is a point. I'm going to plug 4 in. The square root of 4 is 2 cubed is 8, so it's 16 thirds. 16 over 4 is 4. And then 0 minus 0. So we get 4 thirds or 1 1/3. Doesn't matter either way, and that's a point. You could have done it with horizontal slicing. So I'll just show that real quick. It's going to be x right minus x left. So x right in terms of y is that line. It's 2y. X left is y squared. dy. Integrate in the y direction 0 to 2. So that would be your setup that you could have totally done this way. You get that same point. Antiderivative is going to be 2y squared over 2 minus y cubed over 3. 0 to 2. That's a point. Antiderivative. Plug 2 in, you get 4 minus 8 thirds minus 0 minus 0. 12 minus 8 is 4 thirds. That's your point. Or 1 1/3 if you want to do extra work, which I wouldn't do. Sometimes you guys mess it up. So either of those ways, okay? Part B says, the region R is the base of a solid. So this is volume by cross sections. For the solid, the cross sections are perpendicular to the x-axis, and they're squares. So they got to be up and down, and they are going to be squares. Okay? They're going to be squares. So let's set this up. let's see, volume equals some area formula. They're squares. And this, you have to do vertical slices. You don't have the option. It's going to be side squared. We're going to integrate in the x direction, 0 to 4. Now, the sides, you always want to use the bottom of the slice that's touching the base region to figure out your dimensions. It's y top minus y bottom. In terms of x, so y top is the square root of x, y bottom is x over 2, and it's going to be squared dx. So that's your setup. And that's worth 1 point. So then we need to integrate. Now, to do this by hand, I think we should multiply this all out. So that's going to be x minus x to the 3 halves. So it's going to be minus x to the 3 halves plus x squared over 4. So I'm doing some work in my head there. If you don't feel comfortable with that, then show a little more work. But we're foiling it. You can't just distribute exponents. So that's x to the first minus 1/2 x to the 3 halves minus 1x to the 3 halves. That's minus 1x to the 3 halves. Negative x over 2 times negative x over 2 is positive x squared over 4. So then we x squared over 2 minus x to the 5 halves divided by the new exponent multiplied by the reciprocal plus x to the 4th over 16. So that's a point, your antiderivative. And then we got to plug numbers in. So we're going to get 16 over 2 is 8 minus square root of 4 is 2 to the 5th is 32 64/5 plus you could take a 16 out of this. There's going to be 16 left minus 0 plus 0. So this is going to be 32. Least common denominator is 5. 160 minus 64 is 96 over 5. But I think I messed up. What did I mess up? Let's see. Oh, shoot. This is x cubed over 12. What did I do? X cubed over 12. I like squared it again. So that should be 64 over 12. Now I guess I would have lost potentially 2 points. We could take a 4 out of this. That's 16 over 3. So least common denominator would be 15. Well, 15, 3, 5. Okay, so let's see. 80, 120. I'm just going to show my work. 120, 192, and 80. So it's 200. That's 8/15. Okay, that's the right answer. Oh my gosh. That's the point. Okay, be careful. I did something just stupid there. All right, C. What do you think it's going to be? You think you're going to be surprised? We did area problem. We did a volume by cross section. I wonder, might it be a volume by solid revolution? Right, but do not evaluate. So we're going to let you off the hook here. You just have to set it up, an integral for the volume of the solid generated when r is rotated around about the line y equals 2. Now I'm going to go ahead and just draw it up here. I feel okay about fitting it all up here. So we're rotating it around this line. So I'm going to try and just sketch another half of it. Now we can do this 2 ways. If you want to do disc washers, which you're probably more comfortable with right now, you can do that. I'm going to use my other slice that's already on here just to try not to make too much extra mess. It'd be perpendicular to the axis of rotation. It's a big disc with a small disc inside of it that we got to subtract. These are going to be y top minus y bottom. both of them. Different y tops, different y bottoms. So the setup for that, you pi r squared dx minus pi little r squared dx. That's one big disk minus one small disk. Integrate them. The limits are going to be in the x direction, 0 to 4. The big radius is going to be y top, which is 2, minus y bottom, which is x over 2. So it's going to be 2 minus x over 2 squared. The little radius is going to be the one inside. It's going to be y top, which is 2, minus y bottom, which is right here, which is that, the parabola. So it's going to be 2 minus the square root of x squared dx. And that's it. That's all you have to do. You don't have to find the answer. The points here, there's 3 points. So 1 point for the constants and the limit being correct. Don't forget the pi, get the limits correct. 1 point for this, 1 point for this. You got to have the minus probably to get that point. So there you go. We can do the shell method. I'll show you guys. Tomorrow, like I said, we're going to get a little more into it. You would slice it parallel to the axis of rotation to get your shells. Shells have a radius, which isn't dependent on the curves, and they have a height. So this is like a sideways shell, right? The volume of a shell, you open it up, it's a rectangle. So it's base times height. The base is the circumference, 2 pi r, times the height of the shell. And then the thickness is going to be dy this time because they're horizontal slices. The limits are going to be in the y direction, bottom to top of that region, 0 to 2. The radius is going to be gradually changing, not based off the curves, but based off of what slice we're at in the y direction. It's going to be y top minus y bottom. Y top is 2, y bottom is just whatever y we're at. It doesn't depend on the curves. 2 minus y, okay? The height is the thing that depends on the curves. That's changing because of the curves. It's the distance between the curves. So it's going to be x right minus x left in terms of y. So x, actually I'm writing in the wrong spot. I should write it down here because otherwise I'm going to mess myself up. You want everything to be based off this original region, okay? X right is the line, which is 2y, minus x left is the sideways parabola, which would be y squared. So it's going to be 2y minus y squared. 2y minus y squared dy. Point, point, point. Now, they didn't tell us to evaluate it, but we could just for fun right now and check our answers, see if they could both give us the same thing. If they both give us the same thing, probably did it right. Okay. So pi math 9 parentheses 2 minus x over 2 squared comma x comma 0 comma 4 minus pi math 9 parentheses 2 minus the square root of x close squared comma x comma 0 comma 4. I mean, you guys should be able to crank these out. Let's see. Take a deep breath while you're waiting. 8.377 or 8.378 if you really want to round. I'm just doing this check this. You weren't allowed to use a calculator on this. So the next one would be 2 pi math 9 parentheses 2 minus x parentheses 2x minus x squared close comma x comma 0 comma 2. Same answer. That's a good sign, right? Now, the answers weren't exactly the same. Right here at the 6th decimal place, they started to divert from each other. If you did the work, which you could do, you would get 8 pi over 3 for either approach. So that's it. Some good practice. Tomorrow we're going to try and get more serious about the shell approach and force you to start to get used to that. And then that'll be it. We've covered everything that's on your next test.